Making sure that we have the right permissions set on our files can help protect the confidentiality and integrity of our systems. So in this exercise, we're going to go over Linux permissions on files. We're going to take a look at read, write, and execute permissions, the user, group, and other. And then we're going to change permissions using chmod. Now, fairly intuitive. You can read files if you have read permissions. You can write and modify files if you have write permissions. The execute permissions is a little bit different. If you download a file off the internet on a Linux system and it's just sitting there on your computer, you can't just run it. You have to add the execute permissions. I've heard some people say this is what helps protect Linux users. Like if your grandparents don't want viruses, this execute permission will help protect them from accidentally installing malware. In my opinion, that's a little bit overstated, but it's different. So applying execute permissions manually, intentionally, is something that can provide us some protection. There are a few ways that we can apply these permissions. There aren't a whole lot of places in the computing world that use the octal format. So we've got decimal numbers 0 through 9. We have binary numbers, which are just zeros and ones. Here, we use an octal format. We can use an octal format. So octals, the values 0 through 7. So inclusive of 0, we've got 8 digits to work with. So in the Linux world, when we're using the chmod program, we can come up with any combination of read, write, and execute permissions using the values 4 for read, 2 for write, and 1 for execute. So how does that work out in practice? Well, here's a table showing every single combination where we're granting read or not granting read, granting write or not granting write. Same thing with execute. So if we want to grant someone read access, we give them 4 points. If we want to grant write access, we give them 2 more points. If we want to grant them execute access, we give them 1 more point. You can kind of think about it as points. So those points, we can add them up to get this sum here. So with 3 different permissions where each can be yes or no, we have 8 possible combinations. So let's look at the top and the bottom first. If we don't want to give somebody read or write or execute, that's 0, 0, 0, which gives us a total sum of 0. If we want to give somebody read access and write access and execute access, that's 4 plus 2 plus 1, which gives us a total of 7. So we can see for every single combination, we just add up 4 for the read column if it's a yes, 2 for the write column if it's a yes, and 1 for the execute column if it's a yes. So for example, if we want to give somebody read and execute, that's 4 plus 1 would give us a value of 5. So if I apply your permissions as the number 5 to a file, that means you get read and execute. Very frequently when setting up systems, the vendor will give you documentation. They'll say, make sure run chmod like 600 to this file. So you don't necessarily always have to figure out what permissions to apply. Many times the instructions will tell you, and those permissions will get applied. So let's go through a few examples here. So let's make sure that we're in our home directory. Let's do this. So if you just do cd, that'll take you home. We can check with pwd. And let's make a directory called permissions. So make dir permissions. And then we're going to cd permissions. I'm going to use my tab completion. And we're going to create a couple of files. So we're just going to use touch. So I'm going to touch program, touch watch, and I'm going to touch write. So if I run ls, I can see I've got 3 files there: program, watch, and write. So if I run ls-l, I can see the permissions. So we've seen this before, but we've never really dug into it. That first column, that first dash, that tells us if it's a normal file or if it's a directory, for example. So we're going to ignore that one for now. But the next 9 columns are all about permissions. So we have 3 groups of 3. So we've got RW dash. This means read, write, no execute. Read, write, no execute. Read, write, or sorry, read, no write, no execute. So this applies to the user, the group, and other. So it's like everybody else. So I see the Ubuntu user owns this file here. All right. So user group and other, those are the 3 combinations. Let's take a look. Let's create a small program here. So we use Nano. We won't be super hackers and use Vim right now. So I'll say Nano program. And we're going to create a very small program. All our program's going to do is echo hello world. So I'm going to Control O to save, Control X to exit. Now I can cat program, and it's got the contents echo, and then in quotes, hello world. If I try to run this program, I can't. If I try to say /program, it says permission denied. That would be the syntax for trying to execute this program, but notice I don't have execute permissions. I mean, I just created that file, for goodness sake. Should I be able to execute my own stuff? Well, I've even denied permission to myself to execute that program. One way that we can apply this permissions is if we do chmod plus X to program. So this is going to say, like, change the permissions by adding execute, and it's going to add it to user group and other to the file named program. So now if I run ls-l, notice my program is highlighted in a different color this time, showing that it's a program that I can execute. And previously I just had no X's on program. Now I've got 3 X's showing up. So because I did plus X, I didn't specify the user, group, or other. This execute permission was given to anybody. But it's such a good program, we want everybody to run it. So we can run it. So in the current folder, so /, I can run program again, and it says hello world. So once I granted myself execute permissions, I could actually run that program. So it's a very common use case. When you edit a file in Linux and you want it to be executable, you have to add that execute permission specifically. All right, so if I chmod -X, that's to remove the permissions from program. Now if I ls-l, nobody can run it anymore. So if I try again, program permission denied. So this is different than Windows. If you download an executable and it's in your downloads folder, you just go double click on it, it's going to run. Like that execute permission is there kind of by default when you create a file. Different in Linux. Okie dokie, let's take a look. We can specify permissions to the user, group, or other. We don't have to do it to everybody. If I do ls-l, I'm going to check something real quick. In this case, the group, user and group both have write access to everything. We'll just run these commands. If I do chmod g + plus W. So that's the group. To the group, add write permissions. To write. Those permissions, it just confirms that those permissions are there. If I did G minus W, write, I just, to that write program, well, sorry, group, you just lost your write access. So if somebody else was in the Ubuntu group, but they weren't the Ubuntu user, they could not make changes to that particular file. So I can add it back. We'll see that W appear. chmod G plus W to write. Let's not use the chmod command. We use chmod like normal people. I don't know, do normal people use chmod? It's a philosophical question. I'll leave that one up to you. ls-l, we restored that W. If we want to remove our own write permissions, we could do that. Why would you want to do that? I don't know, just because you don't want to accidentally make a change to a file, perhaps. You made a backup of something and you don't want to accidentally delete it. I know some IT administrators who have accidentally deleted all the database backups and deleted all the security camera footage accidentally. So maybe sometimes you do want to remove your own write access. So let's do that. So chmod u minus W, that's to the user minus W, watch. So if we just want to watch it, we don't want to write. If we run ls-l, now we've lost write access to that file. Kind of a bummer. So let's see how this goes. Let's try nano watch. Notice it says watch is unwritable. Well, that's sad. So sad. We can't make changes to it. So I'm going to Control X, exit out of nano. All right, you want to see something crazy? It's going to blow your mind. I'm going to vim watch. Can vim do it? Just do it, vim. Escape to get out of insert mode. Right click. Is it going to do it? Place your bets. Is vim gonna do it? So powerful. Read only. Add exclamation point overwrite. All right. Do it. What? What? What the heck? Vim just did it. What the heck, Vim? ls-l. My watch does not have write access, but I just wrote to it. What the heck? This is a slight detour, but what Vim just did right there, it used chmod in the background basically to give me write access, wrote the changes, and then removed my write access again. So Vim, super powerful, super hackery. But there we go. Now, if we want to use chmod, we can change a lot of permissions at once. So let's use the octal format. So I'm going to create a new file. I'm going to touch perm test.txt. So I'll ls-l. So what the heck are we going to do? We're going to chmod 777, chmod 777 to perm test.txt. So what is this going to do? What does 7 mean? So we get 4 points for read, 2 points for write, 1 point for execute. We add them all up, we get 7 points. So this means the user's gonna get read, write, execute. The group is gonna get read, write, execute, and everybody else, other, is gonna get read, write, execute. So if I run that, Linux is like, cool, I don't care what you're doing. ls-l. And that perm test.txt, even though it's an empty file, there's no program in it. Everyone's got read, write, execute. So we could do that just instead of saying user plus write, group plus write, other plus write, user plus read, group plus read, other plus read, user plus X. Instead of doing all that, just with these little 3 numbers here, we can specify 9 total permissions for the user, group, and other. And we can do any combination of numbers 0 through 7. So we could chmod 560 to perm test.txt. So let's think about what did that actually do? So what are the user's permissions now to this file? 5. Well, how do we get 5 with the numbers 4, 2, and 1? There's only one way. So 4 is read, 1 is execute, 4 and 1 give us 5. So the user should have read and execute, but not write. How do we get 6? Well, we can only make that with 4 and 2. So the group will have read and write, and other, how do we get a 0? Well, with nothing. The other will have no permissions. So let's check that. Let's run ls-l, and let's check those permissions. So yeah, on perm and test right now, the other, they can't do anything because they had a 0. We had 4 plus 1, so we can do read and execute. And the group had read and write 4 plus 2, so they can read and write, but they can't execute. So any combination we can do with the numbers there. There are oftentimes your software won't work unless you have the right permissions, because they want to make sure that the correct write access has been restricted to files so that you don't actually leak security details. Like, you don't want to give read access to the wrong people, especially if on your server, if you're making some of these files available to the public, you really want to make sure that you have those permissions correct. Some programs, if they see a security problem, like with some of your cryptographic keys, the program's just going to say like, yeah, I'm not even going to try to do this because you're doing something dumb. You got to fix your file permissions before we actually let you turn on some of these services to the world. So in the end, we have to understand what these permissions are. We can evaluate them with ls.l. Look at those read, write, execute permissions. We can use chmod. We can use chmod to change those permissions. We can use the octal format, use chmod with the numbers, or if we want to make very targeted changes, small changes, we can use the other syntax where we just user, group, or other. We can add or remove specific permissions.